Hello everyone. So we have this good question from the chapter of electromagnetic induction, and with this question you will also be able to revise some of the concepts of RC circuits. Okay, because there is a resistor and a capacitor here. So yeah, let's just go through this question once. So it has been said that the magnetic field in this region decreases linearly with time. Okay, and the it's a circular loop which has a radius a, and there's a resistor, the wire has resistance a and capacitance c. Okay, and it has been placed normal to the field, and we have to find the maximum charge on the plate, and we have to find which plate will be at a higher potential when it is fully discharged. Okay, so let's begin. Okay, so first things first, let's find out what the EMF induced will be. Okay, since there's a changing magnetic field, we know that EMF induced will be equal to minus d phi dt, right? Where phi is the flux, in flux which is linked. So this we can write this as minus a dv dt because area will remain constant. So this will be minus pi a square, and db dt, it has been given in the question, is minus k. So the EMF which will be induced in the loop will be this. Okay, so the maximum current which can be in this loop, let's consider that to be I naught, will be equal to E by R. No? This is the maximum current. So this will be pi a square k by R. Okay. Now let's find what will happen after a time t. Okay. What will be the current? What current will be there after time t? What will be the charge? We have been asked. What we have been asked to find what the maximum charge will be. Okay. So yeah, we know that the relationship of current at a time t is something like this for an RC circuit, right? So we can just write I to be dq dt, and then I naught will be equal to k pi a square by R, and this is e to the power minus t by RC. Okay, so integration dq will be equal to k, this will be equal to k pi a square by R e to the power minus t by RC dt. Okay, so upon integrating we will get q is equal to pi k square divided by R. This will be into minus RC e to the power minus t by RC. Now we can neglect this. We are not considering the charge. Okay, we are considering the magnitude of charge. So let's just ignore this minus sign for a moment here. And upon simplification, the value of charge will be equal to k pi a square c divided by e to the power t by RC. Right. So as you might have guessed, the maximum value of q is equal to k pi a square c. Okay, and this will be when? This will be when t is equal to 0. So at the very beginning, okay, एकदम मतलब initially एकदम the when the value of time is 0, that is when we will have the maximum charge. So we have the first correct answer A. Now coming to option C and D, it has been stated that when the circuit is fully discharged. Okay, now when the capacitor is fully discharged, it has got a charge equal to 0 now. So the potential difference across it will be q by c, which will also be 0. So quite naturally, the potential difference will be the same, right? will be zero. I'm sorry. So the potential difference will be zero. So yeah, the only correct option which we have here is A. Thank you.